This video is on section 10.1 notes, the parabola. So for this chapter, we're studying conic sections, and a conic section is a cross section or a slice of a cone and what that would look like. So here we have a picture of a cone, well, two cones really, or you can think of it as maybe like an hourglass. So a parabola is if you were to kind of slanted, like cut through that cone, and then also cut through the base at the same time. It makes a parabola shape. For an ellipse, you cut through the cone, but you don't cut through the base of the cone, and that makes an ellipse, which is kind of like a squashed circle. A circle would cut through the cone and be parallel to the base. And then over here we have a hyperbola. If you cut through the cone perpendicular to the base, then you have what looks like two little parabolas, basically. So these are the different cross sections of a cone. We'll be studying all of them, and today specifically we're going to look at parabolas. So in the past, we have looked at parabolas from an algebraic perspective. We've looked at them as the graphs of quadratics. So it's y equals an x squared graph, where a is some non-zero coefficient. So we have the vertex form, we have the standard form. That's what we've used before. So now we're going to discuss a parabola from this geometric perspective. So a parabola is the set of all points in the plane that are equidistant from a fixed line called the directrix and a fixed point that's not on the line called the focus. So each time we work with a parabola in the context of conic sections, we're going to be looking at the directrix and the focus. We'll find that as part of our graph, and we'll use it in problems to find the equation. All right, so the equation of a parabola has the focus, where hk is what we always used before to find our vertex. And so the focus is h and then k plus p, and we'll define p in a second. And the directrix is y equals k minus p. And this is specifically if you're talking about parabolas that open up or open down. We will talk about parabolas that are not functions, since we're talking about geometric definitions for this unit, and so not everything has to pass the vertical line test for this unit, which means we'll have parabolas that open to the right and open to the left. So this is going to be an important little formula for you. You could highlight it if you want to. In fact, I'm going to do that. So the a value, that coefficient for the x squared term, a is 1 over 4p, and we're going to find that that is something important. We'll use that in problems. Okay, so here's this. I'm going to give you guys, I'm going to post a little cheat sheet that has some different visuals like this to help you remember some of these different formulas. But this is the format that a lot of textbooks I've seen use when they represent a parabola from a conic section specifically. Our textbook doesn't do it. So our textbook tends to represent these in the vertex form or in the standard form of a parabola. It always relates it back to what you learned in algebra, but a lot of other textbooks have like a specific form that they use for a conic section. And so I'm going to go ahead and use this form, and we'll kind of go back and forth between them because I think this form is pretty user-friendly, to be honest. I mean, they all kind of are, but it would be good for you to be familiar with it, depending on what class you take after this. So this says find the vertex, the focus, and the directrix of y equals x plus 1 squared plus 2. So looking at this, I can use what I've learned in algebra to tell me that the vertex of this parabola that opens up is -1, +2. I can tell that because I've learned about the transformations of quadratics. There's no coefficient in the front, it's not negative, so that means that this parabola is going to open up. But I can go ahead and look at this picture that I'm going to use of information for conic sections specifically, and I'm going to go ahead and manipulate this equation to get it in this form, and then I'm going to use this form to find the information and sketch the graph. So this 2, I can go ahead and subtract over so that it's with y. So I'm going to write y minus 2, and then that will leave x plus 1 squared by itself. And here in this form, they put parentheses around the y. Okay, so the vertex is HK, so it's the opposite sign, opposite sign. So that means for me that the vertex of my parabola is going to be -1, +2. So left 1, up 2. There's the vertex. And then also we have to find the p-value, because the p-value helps us to find the focus, which is inside the parabola, and the directrix, which is outside the parabola. So I'm going to say the number in the front of this would be a 1, since there isn't a coefficient there. And I'm going to say 4p equals 1. And so p equals 1/4. And p is positive, it's greater than 0, so this graph opens up. The parabola is going to be a U shape that goes up. So what I need to do is I need to go up 1/4 and draw the focus. I'm going to go down 1/4 and draw the directrix as a dotted line. So it's not a dotted line like an asymptote, like you probably have drawn in math classes in the past, but it is a dotted line, and that it is not part of the graph. So it's kind of imaginary. It's not something that would actually be part of the points that are being plotted that make the equation true. Okay, so there's the vertex. For the focus, we went up 1/4, and so I'm going to take my y coordinate and I'm going to add 1/4 to it because we went up 1/4. So we can write this as a mixed number if we wanted to make it a little easier to add the fractions. In most cases in this level of math, we used improper fractions, not mixed numbers. So I'll go ahead and convert it to an improper fraction. 2 times 4 is 8. 8 plus 1 is 9. And so that's 9/4. -1, 9/4. Okay, and then the directrix is a horizontal line, so that's a y equals equation, and it went down 1/4 from 2, so that's 1 3/4. I just subtracted 1/4, and again, most people would not write this as a mixed number. Most math people would not, so I'm going to go ahead and write this as an improper fraction. 1 times 4 is 4, 4 plus 3 is 7, so that's 7/4. So the focus is -1 9/4, the directrix is y equals 7/4. Okay, from there they said to go ahead and graph the parabola, and so for us, for each of the graphs in this unit, we're going to be graphing by hand, and we're going to make sure that we have efficient ways of doing so. So one thing that's important to know with parabolas is that whether you go up and down or whether you go left and right, a parabola's typical growth is to go over 1 up 1, over 1 up 3, over 1 up 5, over 1 up 7. So it does the odd numbers, 1, 3, 5, 7. 1, 3, 5, 7. And each time it just goes over once and then it does that growth pattern. And so if we have a 1 here as the coefficient, then we're not going to change this growth pattern at all. This graph hasn't been stretched, it hasn't been compressed, it is just typical, it's got a 1 in the front. And so then I can go ahead and just graph this growth pattern the way that it is, and that'll be my parabola. So I'm going to go over 1 up 1 on each side, and then over 1 up 3 on each side. If I had space, I could go over 1 up 5 and then over 1 up 7, but I don't. So I'm just going to leave it like this. And there's my graph. All right, let's go ahead and do this again. So here it says find the vertex, focus, and directrix of this equation. So it gave it to us again in that kind of vertex form, but this time the x and the y are traded, which means that this is going to be a sideways parabola. So I'm going to go ahead and convert it into this form right here so that it's the more like conic friendly form. So I'm going to add 6 over to the side with the x plus 6. And then we'd add the 6, and then to get rid of the 1/4 right here, because you can see there's no coefficient for this term, it's actually on the other side. To get rid of the 1/4, I would just multiply by 4 over to the other side. So I'm going to put parentheses in front of this, and then I'm going to multiply the 4 over. So I'll put a 4 right in front of this. Equals y minus 2 squared. Okay, and then we can see from this that the vertex is still hk, and the h still comes from the x, and the k still comes from the y, so we're going a little bit backwards this time. Okay, so hk, our vertex is -6, +2. Vertex is -6, +2. 6 and 2, okay. And then we need to go ahead and find the value of P so that we can draw the focus and the directrix. So right now we have 4P is equivalent to 4. 4P equals 4. So we'll divide by 4, and we get P equals 1. All right. So P equals 1, which means that for this, that's +1, so this graph opens to the right. Okay, and so the focus is going to be inside of the parabola as it opens to the right, and the directrix is going to be a vertical line to the left. So here's the focus, here's the directrix. Okay, so focus, take this, go to the right, so that's -5, 2. Take this, go to the left, that's going to be -7. And that's an x equals equation because it's a vertical line, so x equals -7. Okay, so now I'm going to go back to my previous page of notes because I said something to you guys that was a little bit misleading, and I apologize for that. Okay, so for us to figure out what value it was that we were going to either stretch the graph or compress the graph, we're not using, this was coincidentally a 1, but we're not using the number as it is right here. We have to think about what the A value would be, because the A value is the number that tells you your stretch or your compression. Okay, so we're going to edit our notes over here a little bit. We're going to say A gives you stretch, vertical stretch, or compression. And so for this particular graph, the A value, which has a formula of 1 divided by 4p, the particular A value for this graph was 1 divided by 1, which is why it was just a 1, it worked out. So I'm going to write A for this graph, 1 over 4p was 1 over 1. So there was no stretch, no compression. Okay, that's important. All right, let's move over to this graph that we're about to do. So I'm going to write the pattern. We have 1, 3, 5, 7. This is the pattern that graphs go by. So if we were going up and down, we'd go over 1 up 1, over 1 up 3, over 1 up 5, over 1 up 7. But we're going to go sideways this time. So the pattern for a sideways parabola would be up and down 1, and then 1. Up and down 1, and then 3, up and down 1, then 5, and then up and down 1, then 7. So we're going to do that pattern, but sideways. And then we have to think about if we have a stretch or compression, this time not vertical, this time it's horizontal. So for this, we have our A value is 1 over 4p, which in this case is 1 over 4. 4p in this case is 4. So for us, our A value is 1/4. Okay, so for this, we're going to take our normal growth pattern, 1, 3, 5, 7, and we're going to multiply it by 1/4. And so the growth pattern that we're going to draw is 1/4, 3/4, 5/4, 7/4. Okay, I'm going to go ahead and turn my paper sideways. All right, so here's my parabola. I'm going to go over 1 on each side, and then instead of going up 1, up 3, up 5, up 7, I'm going to go up 1/4, 3/4, 5/4, 7/4. So over 1, up 1/4, over 1, up 3/4. 1/4 and 3/4 brings you all the way to 1. So we went up 1 total. And then over 1, up 5/4. So that's 4/4 plus another 4th. And then the next one is going to be over 1 and then 7/4. So we got 3/4 and another 4/4. 3/4 and another 4/4. And I have a lot of room on this graph. If you wanted to keep doing the pattern, you could. So the next one would be 9/4, so over 1, and then 4/4, 8/4, 9/4. 4/4, 8/4, 9/4. And then the next one would be 11/4. So that'd be 3/4, 7/4, 11/4. So this is what our parabola looks like for this one, since it grows by 1/4. It is wider than normal. And there is our graph. Okay, next, we're going to look at an equation that is in standard form, and we're going to find the vertex focus directrix because standard form is a little bit more difficult. So we have 2 different ways of doing this. We can complete the square, or we could just find the vertex using a formula that allows us to find the vertex. So first thing I'm going to do is complete the square. I'm going to go ahead and start with the y and move this constant over to the side with the y. So I'm going to say y minus 2 equals -3 x squared minus 6x. And so my goal right now is to get the equation to look like this. The sides are backwards, but that's what my goal is. So I'm going to keep my goal in mind. Okay, so what I'm going to do now, I want x minus h squared. So when I complete the square, I always take this coefficient out. So if I factor out a -3, I get x squared plus 2x, and then I leave my blank to complete the square. So I'm going to take my middle term and divide by 2 and square it. So 2 divided by 2 is 1, 1 squared is 1, and so 1 is the number that completes the square. But I didn't really add 1 to the right side. I really added -3 times 1 to the right side. And -3 times 1 is -3. So whatever I do to the right side, I have to do to the left side as well. So I'm going to do a -3 on the left side. Okay, so on the left side, I have y minus 3. On the right side, I've got a -3, and then I can put something in parentheses squared. And if you guys recall, whatever number you got when you divided by 2, that's what goes in the parentheses. So this would be x plus 1 squared. Okay, so this is a pretty good match for this form, almost. We're pretty close to it. So I'm just going to write the x plus 1 squared on the left side, and I'm going to take that -3 and divide it over to the other side. So x plus 1 squared, y minus 3 is already on the other side. -3 I'm going to divide over, so I'm going to have 1 divided by -3. Okay, so now it's in that form where I can use this to help me figure out my information. So they want the vertex, the focus, and the directrix. So my vertex is just going to be HK. So the vertex is -1, +3. Oh, I wrote -3, but I meant to write -5. Sorry about that, you guys. 2 and 3 makes 5, not 3. Okay. So my vertex is, because of the -2 and the -3 together, -5. My vertex is -1, +5. Okay. Next, the focus. To find the focus and the directrix, we have to know the value of P. So I'm going to say 4P equals 1 over -3. To get the P alone, I can multiply by 1/4 on each side. You can divide by 4, or you can multiply by 1/4. And so P equals -1/12. So I just took the negative, moved it into the front of the fraction. 3 times 4 is 12, -1/12. Okay, so for the vertex, I have -1, 5. So left 1, up 5. I just want to picture this. This negative tells me that my parabola opens down, it does not open up. So I'm going to draw a little sketch going down. Okay, that means that my focus is underneath this point and my directrix is above this point. Okay, so for my vertex, I need to go down 1/12 to find the focus. So -1, 5, if I go down 1/12, that would be 4 and 11/12. Okay, I need to go up 1/12 for the directrix. Horizontal lines are y equals. From 5 to go up 1/12, we would have 5 and 1/12. Okay. Now, most people wouldn't write the focus and directrix like this. Most people would write these mixed numbers as improper fractions. So I'll go ahead and rewrite those. 4 times 12 is 48. 48 plus 11 is 59. So 59/12. 5 times 12 is 60. 60 plus 1 is 61. Okay, so there's the focus and directrix there. So we found the vertex, the focus and directrix, and the process that we used to do that was completing the square. Okay, now we're going to approach the same problem, but we're going to do this by using the formula for finding a vertex. So the formula for finding a vertex is you use x equals -b divided by 2a. And then once you have that x coordinate, you plug it into the equation to find the y coordinate. Okay, well, and actually I could say we can do h and k. There we go. Okay, so we'll go ahead and do this formula. We're going to say that the vertex is negative of -6 divided by 2 times -3. So that's -b divided by 2a. So 6 divided by -6 is -1. Okay, and then the k value is going to be -3 times -1 squared minus 6 times -1 plus 2. So -3 times +1. -1 squared is +1, so that would be -3. +6, and then plus 2. And so this is 3 plus 2 is 5. All right, so the vertex that we get here is -1, 5. Okay, then from there, to be able to find the p-value, we're going to say a equals 1 over 4p. So -3, the a value is 1 over 4p. And so I'll go ahead and multiply 4p over here, get it off the bottom of a fraction. -12p equals 1. And then I'll divide the -12 to the other side. P equals -1/12. And then from here, the math is the same as the other side. So from here, we can say, well, this is a negative in the front of the graph. And so I know that that means that this graph is upside down. And so I could say I have my vertex, -1, 5. This goes upside down. My focus is going to be inside of my parabola. My directrix is going to be outside my parabola. And so if this is inside, I'm going to subtract 1/12, which gives me the -1 and 59/12. For the directrix, I'm going to go up 1/12. I'm going to add 1/12, which gives me y equals 61/12. So 2 different methods for finding the exact same information. Now, on my math lab in the textbook for these problems, they're going to force you to use one method or the other. So I want you to pay attention to that when you do your practice assignments, whether you should be completing the square or doing the vertex. My guess is you guys are going to like this option better. But pay attention to this option because for the rest of the sections in this unit, you will only be able to complete the square. There won't be this to help you out with the other conic sections. So completing the square, we're going to have to make sure that we can do this. Now, I will post another video. Maybe I'll see if I can find some videos to post on Moodle, just in case you're a little bit rusty on completing the square and you need some more examples. All right, now what we're going to do next is we're going to take some of this information and we're going to use it to write the equation of a parabola. Now, in most textbooks, when they're doing problems in this context, if they have you write the equation of a parabola, they have you write this equation. But when I was looking at your guys' textbook, when they have you write the equation, it looked like for the most part, they wanted you to write the equation in standard form. And just a reminder, standard form is y equals ax squared plus bx plus c. So what we're going to do is we're going to take the information, we're going to start off by writing it in this form because this form is really helpful. And then from there, we'll convert it to standard form just so we know how to answer the questions in our own textbook. Okay, so this problem says find the equation of a parabola with the vertex 2, 4 and a focus 2, 5. And when they give you 2 pieces of information like that, giving you the vertex gives you the majority of the equation, right? We need to have either the x minus h squared, y minus k, or we need to have the y minus k squared, x minus h. So that first piece of information with the vertex gives you a lot of the equation. The focus is going to tell you if the equation is opening left or right or up or down, depending on which side of the vertex the focus is on, because the focus is always inside of the parabola. So whenever I have problems like this, I always draw a little sketch because that just helps me with my brain. I'm kind of visual that way. So I'm going to go 2, 4. And then the focus 2, 5 would be a little bit above that. And so that means that we have a parabola that is opening up. And so I'm going to go ahead and use this right here to help me do this problem. So vertex is 2, 4, focus is 2, 5. I'm going to write x minus h squared equals 4p y minus k. And so 2, 4, there's my h and k. Since the focus is up 1, that means the p-value is 1. And so then right here, 4 times 1 is 4. Okay, so write the equation in standard form, find the intercepts and the axis of symmetry. So the axis of symmetry is pretty easy to find. That's just this vertical line that cuts the parabola in half. And vertical lines are always the equation x equals. So the axis of symmetry, AOS, axis of symmetry, is just x equals, and then whatever the x coordinate is of the vertex, because that's part of the axis of symmetry. So x equals 2 is the vertical line that cuts the parabola in half. So axis of symmetry, pretty easy to find. Intercepts we're going to find after we write the equation. Okay, so to write the equation in standard form, I need the y to be alone. So I'm going to go ahead and I'm going to move this 4 over to the other side. I'm going to multiply by 1/4 to get rid of it, or think of it as like dividing by 4. So 1/4 x minus 2 squared equals y minus 4. And then I can go ahead and add the 4 over. So just put plus 4. Okay, so my y is alone now. So I've got 1/4 x minus 2 squared, so I'm going to write it twice, with a plus 4 on the end. That equals y. All right, so now I need to take the two parentheses, and the very first thing I'm going to do in this process is I'm going to FOIL these out. So x squared minus 2x minus 2x plus 4. Negative 2 and negative 2, that gives me negative 4x. Okay, so now I can take the 1/4 and I can distribute it inside the parentheses. So 1/4 x squared minus 1x plus 1, and then that takes care of the parentheses. Now I have a plus 4 on the end. So the equation in standard form is y equals 1/4 x squared minus x plus 5. Okay, so now I need to find my intercepts. I have two types of intercepts. I have x-intercepts and y-intercepts. So my y-intercept is when the x-coordinate is 0. So the y-intercept is going to be the easiest to find in that standard form. If I put 0 in for x and 0 in for x, those 0 out, and I'm left with 5. So the y-intercept, pretty easy to find in this situation. Y-intercept, 0, 5. Okay? The x-intercepts are going to be easiest to find right here. So we're going to have to do some math. Every time we're going to have to do some math, but they're easiest to find right here. So I'm going to plug 0 in for y, because for the x-intercepts, the y is always 0, and then I'm going to try to solve for x. So for the x-intercepts, I'm going to write x minus 2 squared equals 4 times 0 minus 4. 4 times negative 4 is negative 16. Now, you can't solve this, because if we started to solve for x, we would square root, and we'd get the square root of a negative, and that's where we stop. We say we can't solve that. It makes sense, because if you look at our little sketch we did over here, this graph does not cross the x-axis. So as far as x-intercepts go, there are none, okay? So no x-intercepts. However, if we were doing a normal problem, we would just keep going. We'd square root both sides. We'd make sure that for a square root, we have a plus minus, and then we'd add the 2 over. Okay, so this is still the easiest place to go to get those x-intercepts. So I do want to have this in my notes. Okay, we're going to try this again with another set of information. So this time they don't give you the vertex, they just give you the focus and the directrix, but we'll be able to find the vertex from that to start writing the equation, because we know that the vertex is just right in the middle of the focus and directrix. So I'm going to draw a little sketch again. So focus is at 2, 0, so 1, 2. Directrix is x equals -4, and so that means x equals is a vertical line. So 1, 2, 3, 4, it's about right there. And so this is going to be a sideways parabola that's going to the right. So that means we have y minus k squared equals 4p x minus h. Okay, so to figure out what the vertex is, I need to know the distance between these two. And I need to know what half of that distance is. I can tell it's about right here, but I just need to know what that number is. So the distance between +2 and -4. The right minus the left number, the biggest number minus the smallest number is how I'm going to find the distance between them. So the distance between them is 6. And then I want to take that distance, I want to cut it in half. So divided by 2, divided by 2, that gives us 3. So this is a distance of 3, and this is a distance of 3. And that's where our vertex is. It's 3 away from the focus, it's 3 away from the directrix. And so if it's a distance of 3 to the left of 2, 0, that means that the vertex is at -1, 0. Okay, so I can go ahead and start plugging the vertex into my equation. Y minus 0 squared equals 4p x plus 1. Okay, and then the p value is 3. So for this, I can just write y squared. I don't need the minus 0 in there. Y squared equals 12 x plus 1. Okay. Now, to write this in the standard form for an up and down parabola, you'd have y equals ax squared plus bx plus c. If you have a parabola that goes to the right and left, you would have x equals ay squared plus by plus c. So here, instead of isolating the y, we're going to isolate the x. So I'll divide the 12 to the other side, or I can think of it as multiplying by 1/12. So I'm going to have 1/12 y squared equals x plus 1. You can see that our first step is the same as our first step over here. We just took the reciprocal of that multiplier, that coefficient, and moved it over here. And then I'll go ahead and subtract the 1 over. So 1/12 y squared minus 1 equals x. That's our equation in standard form. Okay, now I can find the axis of symmetry and the x and the y intercept. So the axis of symmetry here is the line that cuts this parabola in half, and it goes through the vertex. This is a horizontal line, so it's going to be a y equals equation. So the axis of symmetry is the horizontal line y equals, it cuts through the vertex is at -1, 0, and so the axis of symmetry is the line y equals 0. Right? Next, we'll go ahead and find the x and the y intercept. So we're going to look at the same places we looked here, but they're going to give us the opposite intercepts. So I'm going to look at this stage, I'm going to look right here, and then I'm going to look at the number on the end. Okay, now for this one, I'm plugging a 0 in for the y to get rid of it, and it's giving me the x. And so that means this is an x-intercept. So the x-intercept is at -1, 0, which, you know, that's the vertex. So this x-intercept at -1, 0. Up here, we're going to look for the y-intercepts by plugging 0 in for x. So I get y squared equals 12 times 0 plus 1. And so y squared is 12. And then I just need to square root both sides. Y is plus or minus the square root of 12. And we can go ahead and simplify this. We know that the square root of 12 is the square root of 4 times the square root of 3, which is 2 times the square root of 3. All right, so the y-intercepts are 0, negative 2 root 3 and positive 2 root 3. All right, let's try another one with some information, kind of like that. So focus and directrix, again, we'll be able to find the vertex because the vertex will be right in the middle. So I'm going to draw a little sketch. 3 7/4, 9/4. This is a little bit harder for me to draw for me specifically when I do improper fractions, and so I like to turn this into a mixed number instead. So you can do 7 divided by 4, 1.75, and then say like, oh, I recognize that's 1 3/4, or you could take, nope, that says decimal. There we go. Or you could take the leftover decimal and turn it into a fraction. So this would be 7/4 to start with was 1.75. And then I took the 0.75 and turned it into a fraction and I got 3/4. So that tells me that the mixed number is 1 3/4. I'll go ahead and do that again for the next one. So 9/4. 2.25, so that would be 2. And then if I didn't know what 0.25 was, I could do 0.25 and turn it into a fraction. That's 2 1/4. So if you have a hard time converting these back and forth, that's how you could use your calculator. So right 3, up 1 3/4. This is up 2 1/4, so up further than that. So this is the directrix and the focus, which means we're going to have a parabola that's going up and down, and the vertex is going to be right in the middle of those. So I'm going to do big number minus smaller number, just like we did before. Big number minus smaller number. So 2 1/4 minus 1 3/4, or we could say 9/4 minus 7/4. And when I subtract those, I'm just finding the distance between those two numbers. And so the distance between them is 2/4. And then to find the p-value, I just want to divide that distance in half. So divided by 2, divided by 2. So 2/4 divided by 2 is 1/4. So the focus is 1/4 away from the vertex is 1/4 away from the directrix. So we're going to say the p-value is 1/4. If I take the focus and go up 1 to get to the vertex, then that means that the vertex is at 3, 2. And then if I go up 1/4 again to get to the directrix, that's 2 1/4. So the math there definitely makes sense. Okay, since this is a graph that opens up and down, that means that I have the equation x minus h squared equals 4p y minus k, and I can go ahead and start plugging my numbers in. So x minus 3 squared equals 4 times 1/4 is just 1, y minus k, y minus 2. The 1 for this time to move this over and be the reciprocal on the other side, 1/1 is still going to be the same, so that's a little bit easier. And so I'll just take this minus 2 and add it to the other side. So x minus 3 squared plus 2 equals y. And now I can go ahead and write my parentheses twice so that I can FOIL them. So I have x squared minus 6x minus 6x plus 9. And I still have the plus 2 on the end. So the standard form of the equation is x squared minus 12x plus 11. And then I can go ahead and find the, I need to be careful. So I've missed a step here. This graph goes upside down, so this needed to be a negative right there. And it's going to make us fix a couple things. So this is going to be wrong. It's a good thing to watch out for. So I noticed that we had a 1 here, but I didn't consider if my graph went up or down. And my graph goes down, which means this one here should have been a -1. Which means that we have a negative right there. And a negative right there. So let me go ahead and fix this. Okay. So that gives us negative x squared positive 12x, negative 9, positive 2. Okay. Y equals negative x squared plus 12x minus 7. So there's our equation in standard form. We're going to go back to the same spots to find our intercepts. So here we can put zeros in for the x's. We have a y-intercept of -7. There's our y-intercept. To find our x-intercepts, we can go right here and plug 0 in for y. So x minus 3 squared is 2. Square root both sides. X minus 3 is plus or minus the square root of 2. And so the x-intercept is 3. I'm going to add the 3 over. 3 plus or minus the square root of 2. Oops. And so the x-intercepts are 3 minus root 2, 3 plus root 2. Okay, the axis of symmetry is a vertical line, so that's an x equals equation. And it goes through the vertex, and the vertex is 3, 2, so it's x equals 3. All right, we have one last problem. So application problems, these are pretty much like the rest. They just give you a little bit of context when they do it. So when a ray of light traveling parallel to the axis of symmetry, so here's your rays of light, your axis of symmetry would go through this, hits a parabolic reflector, it is reflected towards the focus of the parabola. So reflected towards the focus. This property is used in telescopes to magnify the light from distant stars. For spotlights in which the light source is at the focus, the reflecting property is used in reverse. Light originating at the focus is reflected off of the parabolic reflector, so this light goes off here and then goes out, and is projected outward in a narrowed beam. The reflecting property is also used in telephoto camera lenses, radio antennas, satellite dishes, eavesdropping devices, and flashlights. Okay, so this gives the Hubble Space Telescope, which uses a glass mirror. So here's the glass mirror down here with a parabolic cross section. So here's the glass mirror, or the cross section of the glass mirror, rather, and a diameter of 2.4 meters. So here's the 2.4 meters. Okay, if the focus of the parabola is 57.6 meters from the vertex, and they labeled it right here, so 57.6 meters is that distance, then what is the equation of the parabola used for the mirror? So right here is the vertex at 0, 0. And then up here is the focus at 57.6, 057.6, which means that this distance right here that they gave you is the p-value. So I'm going to go ahead and start writing this equation. X minus h squared equals 4p y minus k. We know the vertex is 0, 0. We know the p-value is 57.6. So the first thing they want us to do is find the equation. What is the equation the parabola used for the mirror? And this is the mirror right here. Okay, so I'm going to go ahead and just plug all this information in. So we have x minus 0 squared equals 4 times 57.6. I'll figure out what that is. Y minus 0. And then your textbook, again, typically likes standard form. So I'm going to divide the 230.4 over to the other side, or write the reciprocal, make this a y equals equation. This is not proper what I'm doing right now. I'm going to fix it in a second. So there's the reciprocal. Most people do not put a decimal and a fraction together. Okay, so y is 0.00434. I don't love that because I have to round it to write it down, but there it is. Okay, how much thicker is the mirror at the edge than at its center? So at the center, they're saying the mirror is like, it says 0, 0, so this is like a thickness of 0. And then over here, if we can find this coordinate, we know the x-coordinate is 1.2. We don't know the y-coordinate. The y-coordinate would represent the thickness. So this y-coordinate is the thickness of the mirror. So if I can plug in an x value of 1.2, or I could do it on this other side and I could do negative 1.2. If I can plug in this x value and find the corresponding y value, then I will know the thickness of that mirror. So I'm going to take my equation and I'm going to plug in 1.2. Now, I should never use a rounded decimal when I'm plugging something in the middle of a problem, and so I'm going to use this entire decimal. So I'm going to say times 1.2 squared. This is me plugging it in. Times 1.2 squared. That's the mirror. So the thickness of the mirror, these are meters. That's how thick the mirror is.